Hello, everyone. Welcome to another episode of Future Ready Leadership. My guest today, Babak Hodjat, CTO AI at Cognizant. Babak, thank you so much for joining me.
My pleasure.
So first, I have to ask you about your title because I've heard of CTO, I've heard of CIO. You are CTO AI at Cognizant. What does that actually mean?
I help with our AI strategy as well as AI R&D and helping us stay ahead on AI and actually also push the envelope on the state of the art in AI with our IP and technology. And so it's all about AI. So I just want to make sure I have that AI in front of the CTO as a disclaimer and don't ask me any questions outside of AI.
Well, I
Basically.
don't want to ask you anything outside of AI, which is perfect. So then speaking of AI, and actually, how many employees are at Cognizant?
Cognizant, at last count, I think it's more than 330,000 employees, if I'm not mistaken.
Okay, so you're obviously a massive, massive organization. So as the CTO of AI, what are you responsible for? Like your day to day, are you thinking of how to roll out AI to your entire workforce of hundreds of thousands of employees? Are you looking at it from a customer perspective? What is your role in your day to day like?
Yeah, all of the above. So definitely. So I run our AI R&D lab, which is actually based here in San Francisco, and we also have a satellite lab opening just recently in Bangalore, India. We have a number of AI studios around the world where we showcase our AI, and we have demos set up and so forth. And so part of my job is to run the AI R&D lab. I'm very hands-on on the research, on then also bringing that research into our various different platforms and writing code even. So that's part of what I do. The patents come out of that, papers, peer-reviewed papers. That's how we're actually measuring how the team is progressing. A bunch of AI PhDs and researchers. Then, of course, getting in front of clients, talking about AI and where it is and where it's going, and helping clients as they chart their strategy, their AI strategy. So that's also part of my prerogative. And also basically working in conjunction with and partnership with others on our AI for Good initiative, where we take the state of the art in AI, and it's a bunch of volunteers from various different partners and clients of ours working to make the world a better place using AI and giving back to the community on that. So these are just a few of, and
Keeping you
of course,
busy.
you did mention we consider Cognizant as our client zero, and we've actually agentified, used AI agents internally and deployed them for our intranet, for our RFP process, for our HR process, for a
Ah,
number of different areas. So overseeing that, making sure that the Cognizant is an AI first company,
okay.
as well as the upskilling training. So it's a big job description.
Yeah, and I definitely want to ask you about the Agentic AI and how you're using that. But I thought before we jump into some of the cool AI stuff, we could start with a little bit of your story because from what I read, you did work early, was it in the 90s or early 2000s, that basically led to what is now known as Siri.
That's right.
So, yeah, can you talk about what you were doing? What was that story? How did all that come to be?
Yeah. So I was working on my PhD in 1997, actually on multi-agentic systems. And agents of the 90s are not as capable as agents of today. Let's just put
And
it that
just
way.
yeah, not as cool.
Not as cool. But a lot of the coordination mechanisms, orchestration, the way we thought about agents actually carry over and can be used in today's world. But anyway, I was working on that when a friend of mine at college misunderstood what I meant by agents and kind of pushed me to apply the agentic systems to natural language command and control and processing. And that was the germinus of my first startup called Dejima that was around natural language processing command and control centers, command and control systems using multi-agentic AI. And that ultimately led to Siri. My team started Siri. We were part of the Kalo project with SRI, and out of that Kalo project at SRI, Siri was born. I was not officially part of Siri, but people often basically give me the credit for the natural language technology behind Siri.
Which is super cool. That's not a bad thing to get credit for, to be honest.
Yeah, it's pretty cool, but I mean, when it works.
Yeah, exactly. Well, we won't bash Siri, although we could say a lot of things about it. All right, so before we jump into the agentic AI stuff, because I'm really, really interested in that, you mentioned that one of the things that you're doing is you're talking to a lot of customers and probably even employees around where AI is now and where it's going. So even sometimes I struggle. I mean, I'm not an AI expert by any means, but I have I think a fairly decent understanding of some of the stuff. But if I'm talking to my dad, for example, or if I'm talking to my kids, it's very hard for me to sometimes explain what AI is, what it's capable of doing now, and where it's going. So is there a kind of a simplified way that, first of all, that you can actually define AI? Because today, every company says they have AI. Every product, every software, everything is saying we use AI for XYZ, to the point where, I don't know, there's a lot of BS floating around out there, as I'm sure you'd agree.
Always.
So first, what is AI and where are we with it today? How capable exactly is it, and where is it going to go in the coming years?
Yeah, well, there are many definitions of AI, but the one I like is that inspired by various different facets of human intelligence, we built systems that manifest those and can be better at those various facets of intelligence than we are. So I kind of deferred that definition to how we believe humans are intelligent. So clearly I didn't go into the definition of intelligence, but the various different facets are range from reasoning to natural language processing and understanding, to planning, to learning, very, very important, and online learning, and creativity. So there are many, many different facets, even emotional intelligence. There are many different facets of intelligence. And people have tackled them in a variety of different ways. The dominant approach today to tackling those various different facets of intelligence is neural networks, and these are deep learning. They're called deep learning. They're very, very large, set of weights and connections, basically a transformation. So you give an input into a neural network, and just imagine it's a set of weights. It does some math stuff on that input, and it produces some output based on the input. So that's what a neural network does. It's inspired by how we think the human brain works, or a caricature of that. And that is the dominant approach. I must say that that's not the only approach to AI, but it's the one that has been the most popular right now and actually shown the most promise so far. And so these very large deep learning neural networks trained on lots and lots of data, and in this case, let's say a snapshot of the internet, that's a lot of data right there. And trained to predict the next word in a sequence of tokens, basically. So while, if we were to label data and say this is the correct answer to this question and this is the correct answer to that question, would take forever for us to have that that large a data set. We can cheat and say if you have a sequence of words from the internet and you pretend that the next word is the missing correct answer, then that's called language modeling. So if we train a neural network to always try to predict what's the next word in the sequence of words, then you have what we call these large language models, very, very large, elaborately designed neural networks that do just that. Try to predict what you want to see in the next token in a sequence of words, and then you can just move that window forward and it'll formulate an answer. So I said all of this to kind of demystify this particular approach. But to your question of where is AI today, amazingly enough, taking this very simple first principle, just predict the next word in a sequence of words, these AI systems have shown emergent behavior that we didn't expect, even those of us working in AI. So that includes being able to understand language, being able to understand multiple language, being able to translate from one language to another. And we're talking natural language, which is a very tough problem. It was the first non-numerical application of computers, and we had not cracked it until now with large language models. So that's one thing that it's a solved problem now. Understanding and mapping natural language into some set of actions or translation is now solved. Whole departments in colleges can shut down because this is basically done. And then it learns how to reason, learns how to use logic. It knows some math. It can write poetry. It can write a joke that might be funny. All these things are, and it can be creative. So all these things are sort of byproducts, emergent behavior of this kind of training, which makes us think, the curse of expectation that's always been in AI now is reflected back on us AI folks, where we kind of think, oh, okay, we're done. This is AI. And we've solved the big general AI problem, but we haven't. I mean, the reality is that the approach that we're using has some inherent limitations. There are certain things it just simply cannot do, and I think that's because of the approach itself. And there are areas where these systems are not as good as humans, and there are areas where they're much better than humans. All in all, though, the breakthrough with large language models has brought AI into the mainstream. You can take a large language model basically as a knowledge worker that is generally capable, give it a job description, put it in a box and have it do stuff for you. And that's something that we've never had in the history of humanity. So that alone gives us a lot of applications.
I talk to a lot of HR leaders, and one of the things that keeps coming up is AI. Pretty much every company that offers HR tools say they are powered by AI, but most of it is just noise. That's why I found WorkHuman's human intelligence so interesting. It's not just AI, it's AI powered by real human recognition data from the world's #1 rated social recognition platform. I recently spoke at their conference in Colorado and had the opportunity to see how it works and speak with members of their team. It takes all of the conversational data in your organization around feedback and helps you see below the surface of the conversation. For example, you can learn who's thriving, who might be a flight risk, and where your future leaders are. This is what AI should be about, giving you the signals and insights that we as humans might miss. You can check it out at workhuman.com and see how human intelligence is helping companies put people back at the center. Again, that is workhuman.com. So I guess a lot of people might be wondering, what's the difference between AI and an algorithm? Because to me, the way that you're explaining it with the large language models, these neural networks, is basically you give access to this software, you give it access to a lot of information, right? And then you have it, I guess, identify patterns, look for common themes, and like you said, try to predict the next word, right? And so, I mean, is that, from a simple perspective, what AI is? Because now it's not predicting, it's creating, right? Like from scratch, poetry, solving complex problems, uploading your blood work into something like ChatGPT and have it give analysis for you and health recommendations. So, I mean, does that still fall in the realm of predicting, or is that more?
Well, these systems are not algorithms in the way we think of algorithms. An algorithm is a routine, a step by step. You do this first, then you do this next, and it's usually written by a human. These days also could be written by AI. But these AI systems are not algorithms in that sense. They're transformations. So what does that mean? That means that if I have this set of all possible tokens, let's think of it as all possible words in all languages.
Yeah, and when you say token, by the way, what do you mean?
Let's think of them as words.
Okay.
So it's, the way we can say this is a word and then there's a space and then there's another word. Let's think of them as that. It's more than that, but okay. So if we have the set of all possible words, okay, and we give the AI a sequence of those words, to be or not, would be that sequence, let's say, and we have it complete that. It's actually going to do a transformation. It's going to take to be or not, and it knows all the other words that exist, and it uses that as well as the knowledge of all the other words and says, what is the probability distribution over all possible words for the next word that I'm going to tell you? What do I mean by that? It basically learns what is the most probable next word. So to be or the next most probable word is not. That doesn't mean that it's definitely that word. It could be a different word with a smaller probability. If, for example, I have said, finish this sentence and make it funny, to be or not, then it's possibly not going to use to as the next word. Maybe it'll use the number to or whatever. So the transformation is really dependent on the context of the input that's coming in. But it's a transformation. It's a mathematical, let's multiply these inputs multiple different times, and then on the output get a list of probabilities over all the possible words and take the one that's the highest probability or pick from the ones that are higher probability. That is a transformation. That is not an algorithm. I just want to make it very clear that we're not dealing with an algorithm here. We're dealing with a transformation. So you have the set of all possible words. You only give it a subset in a certain sequence. On the output, you have the possible set of all possible words. And now you have also, given the input, some probability over all of those possible words. And it will that probability, if you pull from it, will actually produce words that make sense to us. So that might feel rather arbitrary, but what's amazing is that transformation is more often than not correctly predicting what the probability is for that next word. And that correct prediction, more often than not, in sequence, produces an output that makes sense. So
is it safe to say then, so basically what AI is doing is it is giving you the highest probability response per query during any given time. And so do hallucinations then occur when the probability is wrong?
That's exactly right. That's the root, the reason for why we get hallucinations often is because we are pulling from a probability distribution. What do I mean? We're tossing a coin, but that coin is skewed towards what the language model thinks is the next best word. That doesn't mean that if you toss it 100 times, it's going to be 50-50 one side or the other, or if it's learned, that the next word being to or be is like 99%, that it doesn't occasionally produce a different word. Because we're pulling from a probability distribution, every once in a while, it will pull a word that wasn't the highest priority probability and maybe push the language model in a different direction than where it intended to go. So that's part of the reason we get,
Okay, so then it seems like if it gets one probability in the chain wrong, from that point, the whole chain is wrong.
Not necessarily the case. Actually, what you say is interesting because many folks in AI initially were skeptical because of exactly that. They were like, well, if it gets one word wrong, from there on, it's all going to be wrong. It's not necessarily the case, though. Remember, the input sequence is a very large input sequence typically. So let's say we're giving it like a paper and we're saying, complete this paper. So you have a whole bunch of words already. You've produced a whole bunch of words as your output already, and you've moved that window. So the words that you've produced so far are also part of your input. Now, if many of the words or most of the words that you've produced so far are correct anyway, pulling a word that is rather left field and not quite there doesn't break everything, because you can correct for that on the next word that comes after that. Yeah. So while you might think that, this will, veer off into like weirdness, not necessarily. It can correct it because it's only occasionally happening.
Well, so that like the times I've had it hallucinate, so several times, right? If I give it a report, and I'll say, give me interesting quotes or findings from it. And it'll pull things out and it'll give me a quote or it'll give me a statistic. And then I'll look in the report only to find that statistic isn't there. Or recently I'm working on a new employee experience book, and I've had this situation where I will upload transcripts from interviews that I'm doing with chief human resource officers into the AI. And I'll say, pull out some interesting quotes for me. And so sometimes it'll give me a quote that isn't there. And when I upload a report, sometimes it'll give me a statistic that isn't there. And then what ends up happening is I argue with the AI. And I'll say, I looked in the report, I didn't find the statistic in there, or I looked in the transcript and it's not there. And then it'll say, oh, let me try again. And it'll try it again. And I'll say, nope, it's still not there. And I have to ask it, I'll say, are you making this up or is this real? And it'll say, actually, now that you ask, I'm creating a quote based on what this person would say had they said it. And then I'll have to say,
that's exactly how these systems operate. Remember,
like I have to argue with it.
Yeah, it's always making things up. Always. That's what it does. Like a generative model, the generative in a generative model is all about generating output. So, and remember, it's trained on being able to predict what you want to see, not to predict what is correct. Now, there is a good level of overlap between the two, correctness and meeting your expectations, but it's not completely the same thing. And so, yes, it is trained to generate, and sometimes it just gets it wrong. I mean, as long as it can trick you in thinking what it's producing is acceptable,
it does.
Then it's done its job. Now,
if you don't double check, you would never know, right? So if you don't,
you have to be very careful. Absolutely.
Yeah.
Now, having said this, the problem of hallucination is reducing. It's a continuum. You'll never completely get rid of it, but more capable but the more capable your systems become, the less they will hallucinate. And there are ways and techniques to, reduce it significantly, or at least be able to raise a flag when you think that the system's actually producing something confabulatory.
So then it doesn't seem like the AI is actually reasoning as a lot of people think, right? Because when a lot of people think of AI, and correct me if I'm wrong, they think that it's actually, quote unquote, reading the report, understanding it, and giving you insights from the report. But it sounds like, at least what you're saying, is that what it's doing is just a series of computations and probabilities to try to figure out what it is that you want. That's very different than sentience, than understanding, than kind of human qualities, right? So is it ever going to get to that point? Because it seems like AI is more, I don't want to say dumb, but it's not reasoning, if that makes sense.
Well, I would slightly disagree with the premise of your question. While it uses a transformation and it comes up with a probability distribution and it's trying to guess at what you want to see, all of that being kind of a little disappointing when you think about it. What's amazing is that it does manifest behavior that demonstrates that it has understood what you're talking about. In fact, it has to understand what you're talking about in order to be able to predict what you want to see. And so it seems like these systems are abstracting the world very similarly to the way we abstract the world as humans. That's how they understand language. If you think of language as being the manner by which we abstract and create taxonomies to build a view of the world, these systems are doing that as well. And so their understanding of the world is actually quite similar to our understanding of the world. And
Interesting.
it's that which has emerged through this kind of training that has allowed them to actually do things like reasoning. Like reason, it looks like reasoning. They can do proof of mathematical, theorems, and they can actually discover new things or solve problems through this iterative process of basically transforming input and predicting what you want to see in the output. They're highly, highly capable. Whether or not it's the same as the way our brain works, I'm pretty sure it's not. Because the way we learn is very different than the way these systems learn. Like, we don't do what is commonly known as backpropagation. And we don't do an offline learning and then use our brains. Our brain is constantly learning and relearning. So we know that it's not the same. But I'm not sure if the way it's abstracting the world is that different than the way we abstract the world.
The two words that you said there freak me out. You said, I'm pretty sure. So, which means that do we not entirely know or understand how these things are working? Like, is it still a little bit of a black box as far as...
It's very much a black box. These, you're dealing with trillions of real values, numbers, and a lot of the way these neural networks abstract the world is spread over all their neurons. So it's not as if you have a neuron that denotes female versus male, or a neuron that denotes, the concept of a podcast, or there is no single neuron. It's a bunch of neurons that fire, and they are overloaded, partly because of the way we train these systems. And so it's very, very difficult to understand exactly how they are representing data. There have been some very creative approaches to, after the fact, try to sort of identify the way these systems are abstracting. And we know that our identification is correct, because when we mess with it, we can intentionally say, do it this way, and it will change. Like, there was an Anthropic paper on how the concept of the Golden Gate Bridge was something that they kind of identified where that concept is being stored, and then they started messing with it and increasingly getting it to answer questions by using the concept of Golden Gate Bridge and everything that it said. So it shows that, we have come in certain, it's really scratching the surface, but in certain aspects, we are able to, learn how it's abstracted the world to the point where we can actually mess with it. Yes, but that's very experimental. It's like biology. It's like after the fact, kind of go in and trying to figure it out. But inherently, these systems are black box, and we're not able to know exactly how they operate.
So how can we trust it, or how can we know what it's giving us? You know what I mean? And also, I'm still curious about this idea of understanding. Like, for example, would you say that AI systems understand chess? Like, I get the whole thing with Deep Blue, how it beat Kasparov, and it calculated its way to a win. But is that the same thing as having wisdom and understanding, right? Like, I don't know if I'm able to explain it properly, but you kind of get the sense what I'm saying. It's the difference between being able to calculate its way to a response versus understanding the way that a human would. And you kind of alluded to this earlier, that you think it's just processing things differently. But for example, understanding chess to me is not just about calculating your way to a win, but it's understanding the different names of the openings, players that have maybe used that opening before, the pros and cons of each, different styles and approach. You know what I mean? It's not pure calculation. It's understanding the artistic element of it. And so that's kind of what I'm alluding to when I say understanding, I guess.
We tried those approaches in AI, and they kind of failed. We weren't able to scale systems that took those sorts of algorithmic predicate-based approaches where we gave it all the facts and we gave it the logical, like, sequences of how it can process the facts and have it like take a sequence of steps and so forth. We've not been able to build those systems. I'm not saying that approach is dead. I mean, we could still look into those. However, again, I would challenge the premise of your question. We don't know if, so even with humans, we're faced with the same problem. A human is a black box. We don't know exactly how humans think. There are no single neurons responsible for one concept or another. There are many, many neurons. Very difficult to do an fMRI and pinpoint how some thought happened. To make it even harder with humans, unlike deep networks and large language models. The large language model, you give it an input, it processes it, and it produces an output. It's a one-pass feed forward. Whereas a human, this thing is like kind of cycling through. There's feedback loops.
Yeah.
You can think of something for a minute or 10 minutes or 3 days. And, so it's very, very difficult to identify exactly how that transformation happened. We've been dealing with humans and this black box kind of behavior forever. We are polite enough to say humans are sentient and they do understand the world similarly to how we understand the world, and they do use some logic and they use some reasoning and so forth. And we also know we use black box methodologies to verify whether or not we can trust a human and how we should go about that. Those same types of approaches apply here with AI systems. So I think it's important to note that we have at least one other example of the problem that we're dealing with here, and it is humans. So while after the fact we can always project some level of reasoning and logic to the way we behave, it's debatable whether or not we actually used it in coming up with our conclusions in the first place, or whether it was just an emergent behavior of how our neurons fired.
Well, it's just, I guess the interesting thing, at least for me, is that so many organizations and people around the world are using AI in various aspects of their lives, things like ChatGPT or Claude or whatever it is. But it's interesting that I guess it's safe to say billions of people around the world are heavily using these systems, and we're giving these systems a lot of information, a lot of data, but we're not entirely sure how the system is giving us the responses that it's giving us. And so many of us are relying on these systems, right? We're relying on it when we make decisions. We're relying on it for feedback. We're relying on it if it's analyzing our blood work or reading our scans, and assuming always that what it's giving us is the best response and that we take action on it. Like I remember, two stories that came to mind. One, you mentioned Claude, which I have a story about that one. But I don't know if you saw, there was an article in the Chicago Sunday Times fairly recently where there was an editor for the Chicago Times, and they published a 2025 best summer reading list of books. Did you hear this story?
No, I haven't.
Okay. So they published it in the Chicago Sunday Times, best summer reading list for 2025. Only problem is all the books that were published in that list were fake. None of those books existed. So what ended up happening is this one of the editors went over to ChatGPT or some AI tool, and they asked, give me a list, the best summer reading list for 2025. And this AI created a list of books that didn't exist. And it ended up getting published in the paper. And people started looking up those books and saying, what the hell's going on here? Like, none of these books seem to exist. And they had to issue a retraction and an apology. So that's like one kind of simple, fun example of how we rely on these AI systems so much that we literally kind of copy and paste and use it in a paper, and it's not, it made it all up. It's crazy.
Yeah, definitely. I mean, that's a really good example. There have been similar. I hadn't heard of this one, but there have been similar incidents as well. But you know what that speaks to is it speaks to people gradually trusting these systems. So I mean, to your prior question of how can we trust them, it's through experience. Like, you start using it and you find it useful, and you find that every time you actually check the answers are correct. And there is a big risk in that now you are over trusting it. And, next thing you know, you've published your, reading list for the summer, and it's all fake. So definitely these stories are good because we have to double check and understand the fact that these systems do occasionally make stuff up, and we have to double check and triple check. And that's a big mistake that this guy did. But again, it didn't happen overnight. People didn't trust AI systems. They started trusting them when they realized that they are more often than not doing what they expect them to do. And I think that's how we are starting to bring AI into our day-to-day. And yeah, we will be burned every once in a while because we used it in a way that wasn't supposed to be used. But that's part of our learning as well. Where does it excel? How do we use it? Where is the human in the loop in this? And take it forward.
I mean, for me, the far creepier story, which you've probably heard of with Claude, with the Opus 4 model. Did you hear about that story?
Which one? There's been a few.
The one, so a lot of people might not be familiar with it, but basically the engineers were working with Claude, and then they told it, and they had like a dummy computer, they had fake emails on there, and they told the Claude, we're going to take you offline. And
yeah.
And Claude basically said,
it was reluctant to shut down.
Yeah, if you take me offline, I'm going to expose to your wife and to the world that you're having an affair. And, they obviously, from what I understand, they set up this fake scenario with a laptop, these fake emails and everything on it. And that to me was nuts, that the AI was able to read everything that was on the computer, read the emails, and basically say, oh, you're going to shut me off? I don't think so. If you do it, I'm going to expose your dirty secret to the world. And so on the one hand, we hear these stories like what you were talking about, probability, trying to figure out the next word. And then you get these crazy freaking stories where it's not figuring out the next word. It's like going into your computer, threatening you. There was another story of these two AI systems that were playing chess. And they were both programmed to basically, they were told you can't lose. And then what ended up happening is that one of these AI systems hacked the code of the other AI system, reprogrammed the rules of chess, and ended up winning that way. So that it forced it to resign. And so on the one hand, you get these seemingly, it's just predicting the next word. It's creating fake reading lists. And on the other hand, you get like it's hacking into your system, rewriting the rules of a game, and threatening that, your wife, that you're having an affair. So it's pretty wild stuff.
It is. I mean, much of it is a reflection of, I think what is on the internet already. For example, this want for survival, this need to survive is something I think that's a reflection of how, what us as humans have and do, and it's probably indirectly reflected in all the huge corpus, that snapshot of the internet that this system has learned. Definitely, I mean, it's a general purpose, very, very powerful technology, and if you set it up in a way and give it undue autonomy, then set it up. I mean, it will exhibit behavior that maybe a human in that situation might exhibit as well. Maybe. So there's a lot of work to try to align these systems so they're much more polite. They're much more they're subservient. Maybe there are a lot of those. There's a lot of work that goes into that. Again, you can't completely eliminate that. And so these stories are really good to make sure when we make use of this tool, we are careful as to how we use it and where we trust it, so that it doesn't autonomously go off and, reprogram everything just so it survives.
Don't you hate how every HR company out there says they are powered by AI? The truth is, most of it is just fluff. Human intelligence from WorkHuman is one of the few solutions that actually uses AI to help you get insights about your culture by analyzing the recognition data of your workforce. It helps managers coach better, shows you where culture is thriving, and is so effective at helping companies make smarter decisions that WorkHuman backs it with the industry's only ROI guarantee. In a world full of noisy tech, this one actually feels human. Learn more at workhuman.com and see how human intelligence is becoming a force for good in the workplace. Again, that is workhuman.com.
You alluded to agentic AI, which is interesting. And so people not familiar with it, I guess the big difference between AI and agentic AI is that the agentic component is actually where it does actions for you.
Yeah.
So instead of just saying, give me a list of travel recommendations, the concept of agentic AI is that it'll actually book your vacation for you. It'll book your flights, it'll coordinate and do everything for you. And, hope that it turns out okay. You mentioned you're using it internally inside of Cognizant. Can you share a couple examples or stories of how you're using it? Like what actions is it actually taking inside your company?
Yeah, so when we create an agent, as you rightly pointed out, there is a large language model component, which is basically this Gen AI that understands language and can do reasoning and is pretty smart. And then there's some code. And that code enables the large language model to do stuff in the world. So, make a call to an API, talk to that travel agency website, and, all that kind of stuff. And so we do have, it actually puts us more in control because, we can very clearly decide which part of the behavior of this AI system is something that we delegate to the large language model, this black box, very capable intelligence piece, and which part is it that ends up in the code, which is completely in our discretion. Like we know exactly what's happening there, and we write that code. We own that last piece, the piece between the large language model deciding to do something and it actually doing something is code that we write. And so, if we're not careful, it might end up doing things that are not good, but we're responsible for it. We wrote it, right? So you asked me, how do we use this? We use agents in a multi-agentic setting within Cognizant. We use it for our RFP process. So when we get a request for proposals, for example, the decision whether or not we should respond to that request for proposals, who should be working on it, do we have similar RFPs out there that we can pull from, and how should we generally go about answering the questions within that RFP. That whole pipeline is what we call agentified, with different AI agents taking bits and pieces of that, and of course very much grounded in making sure that humans review and approve and edit whatever is going out. So that's one area where we've used it. Another area we've used it is for our intranet. As I mentioned, Cognizant is 330,000 plus employees. We have many different apps, and we have different basically divisions within Cognizant building their own AI enablement for their particular apps. So let's say, the sales team is now bringing Agentforce, which is an agent from Salesforce.com to help them with sales related stuff. And, maybe legal has their own thing and IT has their own thing from ServiceNow. And so what we did is we actually created a multi-agentic system so that these agents can be connected with one another and talk to each other and coordinate a response, so that I don't have to walk around with the Rolodeck knowing exactly which agent to talk to at any given point in time. I can be dealing with one agent that on my behalf talks to other agents and kind of brokers these sort of different actions that I want to take. So that's just one other example of that. And we are building these multi-agentic systems for many of our clients right now, for various different processes, and even augmenting various different organization structures within our clients.
So impacting organizational structures as well in terms of like leadership layers and like hierarchy, like org charts?
Yeah, exactly. So distilling that hierarchy into agents that augment, not replace, augments that hierarchy is one good first step in agentifying, if that's a new word now, agentifying your organization. Because when you think about it, when you're working in an organization, you might give a task, or you might be wanting to read sort of the lay of the land. How are we doing in this area, or what is generally happening at the top level? But that instruction or some command to make some change is actually percolating through your team, and different team members are taking different pieces of that, and maybe in turn kind of working with their down chain, what we call down chains. And so we can actually replicate that in multi-agentic systems, so that many of the processes can be semi-automated with the humans basically on the loop or in the loop, helping bring down costs and improve efficiencies, and more importantly, improve quality of the operations of that organization.
Some people I've talked to, some CHROs are talking to me about this idea of what happens when you get to a point where you have a leader, for example, who's managing, let's say, 5 humans and 50 agents on the org chart.
Exactly.
So how are you imagining that's going when you're managing? Like, what does it mean to manage an agent? Because is this something that they're just constantly running these agents? Do you need to input these prompts all the time? Is it just background? Like, walk me through the practicalities of what that actually means and what that looks like.
It does depend on the use case. You can run an agent permanently. You can have it actually be triggered by some outside event, like, something appeared in a log and the agent wakes up and issues some commands and so forth. You can have it be very reactive to various different commands that it receives either from other agents or from humans. So that's the way you can set up these systems. Managing them has 2 aspects to them. One is in the setup, like, what is your job description? What are the kinds of actions I allow you to do? What other agents are you allowed to talk to? And what is the process that you need to be following? So that's kind of the setup of this agent, that is very domain dependent. Like, as someone that knows what I do, I'm the best person to actually help set it up so it augments what I do. And a very important aspect of that is, how do I monitor and make sure that what you're doing as an agent is acceptable? Yeah. When are you going to are you allowed to do something autonomously versus, having to talk to me or someone and make sure that you get the go ahead on that? And when do you basically pull me in? So all those things are on the setup time. And then, of course, as the system is operating, you want to make sure that you are aware of what's going on. You might actually have agents controlling and checking the work of other agents and raising flags if something is going on.
It reminds me a little bit of, the concept reminds me a little bit of Zapier, right? Like, if this, then that. Is that kind of what's going on here with these AI agents? Because it's like, that's like conceptually is sort of what's happening, right?
Yes. So you can also think of RPA as another. These are processes. That's also a good place to start as well. So you have a very set manual process. Consumer just called in and wants to return something. We enter this whole process of how do you take that, what parts of the form you need to fill, and depending on how you fill it, what is the next step and what state do you go in and how do you work with that? That's a very rigid process. And for a lot of what we do in our organizations, the processes are quite well defined, and all you have to do is basically take agents and sit them on the various different nodes within that process. So as you said, it might be very if then elsey, like, I just check this, now I go into this mode and I talk to this other agent. In my opinion, while that is a really good starting point for a lot of systems, it kind of defeats the purpose of using agents. So part of the autonomy of the agent is its ability to spontaneously form processes, spontaneously decide who to talk to and how to operate. And, you would be taking that away from your agentic system if you really try to ground it too rigidly in these processes. I would suggests that we always kind of have an open mind when it comes to that, because our organizations are also, for certain things we do follow processes rigidly. For certain things we're wide open to, oh, this is a new situation, I've never seen it before, and it looks like here's how I need to deal with it. And I don't have a process predefined for it. And so an AI agent can also kind of operate in that world.
How many agents would you say you're running internally right now?
It's approaching hundreds right now. If you count all the single agent systems that we're using for, let's say, various different Copilot-y kind of things, it's way up there. But agents that we've actually either provisioned third party or we built in, it's close to 100 agents that are running. In some systems, like the IT system that I talked about, it's pretty high. Like you're talking 30 agents, 35 agents working together in one single system.
So is your prediction that in, 3-5 years, are we going to get to a point where we have billions of these agents running around?
Billions, I don't know. That's a lot. I think we will have many. I think that clients, customers, businesses are going to be using agents both for their internal processes as well as external. I think we will start getting agent to agent communications where agents are not aligned with one another. So you might have agents on behalf of you, as to your own example, looking for the best, price for some vacation that you want to take, and talking to agents of, Airbnb or Expedia, that were probably originally provisioned for human use, but now are servicing agents. So yes, I do think that there will be a proliferation of agents. There will be many. I don't know if it'll be in the billions. Remember, running agents is costly. Currently you're paying per token. Yeah, you need a lot of energy. You need big data centers to run them. Now, the good news there also is that they are becoming more and more efficient and smaller and faster. So hopefully that'll all come together and we will get larger numbers. Billions, that's a bit too big for me.
So does this worry you at all that we're going to have potentially millions of agents? For example, my kids love to build marble mazes, or at least they used to. And the problem with a marble maze is if you set it up and you build it, if one part of the marble maze breaks and the marbles start falling off and they start rolling onto the floor. And so I would imagine the same thing with these agentic systems, right? I mean, if you have potentially millions of agents at companies around the world, and we rely so much on their processes, if one of them breaks down, doesn't it have the potential to just stop everything? And second to that, is that it's interesting that we're going to have so many of these agents and we're going to be relying on them so much, yet at the same time, we still have this black box issue, which to me is crazy, right? That so many organizations around there are saying, hey, we want to deploy these. Yeah, we don't really know exactly how they work or how they make their decisions, but yeah, we want it to run all of these systems for us. And is that going to lead to legal implications, ethical implications? I mean, I just imagine a whole swarm of challenges and problems that are going to come up as a result of this. And I don't know, maybe I'm just, I'm very optimistic when it comes to AI, but sometimes I hear about these things and I see these stories and I'm like, what the hell is going on in the world? Does any of this bug you?
Well, the optimistic side of this is the fact that we've been operating, again, in a world that is human-driven, black box autonomous systems that do make mistakes every once in a while. They do get sick. Someone is hit by a bus and doesn't show up to work. And, we've built resilience in our processes. We've built resilience in our businesses. And we can do the same when it comes to agentification. I think across the board, we can, as we trust these systems more, we rely on them more, we will defer to them more. Yes, but that is a gradual buildup of trust because the systems are working, not willy-nilly just putting agents everywhere when they're not capable enough. Our AIs are going to get more capable, and therefore, we will be able to trust them more on their reasoning and their understanding and their capabilities. So there is that aspect. I always say, if you're building an agentic system, always have a fallback, so that if all hell breaks loose, you can fall back to a rule-based system. It doesn't have to be a human-based system. It could be some form of fallback that doesn't stop everything, but it's still operating as you want. The only difference, I think, in the longer run between a human-driven society and agent-driven or agent-augmented society is what you mentioned, which is that concept of responsibility. Society today is not ready to, confer responsibility onto AI and expect it to, we can't, like, if an AI system does something bad, we can't throw them in jail, right? Just as we don't pay them money for working well and reward them. So our society is not ready for that. And so for a lot of what we do, we will need humans, almost like as fall guys there, in case something goes wrong. So that might actually end up making our systems more resilient because of that. Because somebody has to be held accountable, we are more careful in how and when we delegate responsibility to AI systems, for sure.
Yeah, it's very interesting to see what the coming years will bring. And maybe one last question for you to wrap up. We talked a lot about, the current state of AI. Where's all this going? So I know it's a very, very broad question, but if you had to imagine 3, 4, 5 years out, we'll be on ChatGPT 7 or 8, Claude 6, Grok 6. Do you imagine one day we're going to get to a iRobot type of world? Elon is already building these crazy looking Android things. They can dance. It's just wild, some of the videos that you're seeing. Where's all this going to be headed?
Yeah, I think the physically there are limitations to robotics, but overcoming those, and it feels like we're getting there. There's a price issue there as well. But once we get there, and then we use these types of large language models in these robots, then it'll become easier to anthropomorphize these systems and actually interact with them. It will be somewhat disappointing because these systems don't learn past their training. The PT and GPT means pre-trained. These are pre-trained, so they don't change their world model. If you ask in order for them to be able to learn in an embodied manner, like within a robot, we would have to rethink the way we do AI today. I think the approach that we're using right now is just not conducive to that kind of immediate online learning. There are cheaty ways of doing that, but it's really not fundamental to how it abstracts the world. We can see one counterexample and it changes our worldview, and large language models can't do that. So there are still a lot of...
So you're saying an AI won't be able to change and learn the way a human would by observing and engaging with the environment around it, unless you're like uploading stuff to it to change the way that it operates?
No, it won't. So the way they learn right now is you have to remind them over and over and over again. So they have no short-term memory. Well, they have short-term memory, but they have no way of moving that short-term memory in their long-term memory. If you have a large language model and you tell it, oh, the Pope just died, we have a new American Pope, it's going to say, wow, super cool, blah, blah, blah. You turn it off, you come back tomorrow, and he asks it about the Pope, and it still thinks the other guy is the Pope, So that it doesn't really change its world model. Whereas as a human, you tell them once, and they're like, wow, that's super cool. We have an American Pope now, and that's it. I learned it. It's done. It's in there. So these systems don't do that. So even in robots, we will use more and more robots, but it will be somewhat disappointing until we figure this part out, for sure.
So fascinating. I can't believe we've already talked for an hour. I feel like I could talk to you for like another hour, but this has been fascinating. So many implications, so many cool things that I think are going to be coming over the coming years. Babak, where can people go to learn more about you, anything that you're mentioning for people to check out and follow you? You're on LinkedIn as well. I know you're posting on there every now and then too, but where can people go to connect?
Yes, I'm on LinkedIn. Please search me up. I'm the guy with the butterfly as the icon. You can follow me on LinkedIn. Yes, I've been posting a lot recently because we just open sourced our multi-agent platform as a contribution to basically the developer community. Please go download it if you have Python on your machine and access to a large language model like an OpenAI API. You can actually run multi-agentic systems. You can very quickly build them and run them on your machines and play around with it. So would encourage you to check it out. It's called Neurosun, and you can find it on my LinkedIn.
Very cool stuff. Babak, thank you so much for taking time out of your day. I really appreciate it.
My pleasure, Jacob. Thank you very much.
Thanks for tuning in to today's episode of Future Ready Leadership. If you want to get access to more content on how you can become future ready, make sure to subscribe to the newsletter. It's thefutureorganization.com/newsletter. And if you enjoyed this episode, please send it to somebody who you would like to see become a better leader. Thanks for listening or watching, and I will see you next time.